Okay, so now let us look at those two problems. Okay, so you roll a die 7 times. Okay, what is the probability that at least one value is observed more than once? Well, this problem we can change, or we can discuss a lot details. First of all, assume that this is a fair die. Okay, so in other words, you have 1, 2, 3, 4, 5, 6, and if you roll a die, the probability of having 1 to 6 is equivalent. So it's both 1 out of 6. Okay, that's one part you need to be careful and assume this is a fair die. Okay. Noticing that a fair die has 6 sides, right? So the probability that you roll this die 7 times, do you agree that you're gonna definitely have at least one of the value observed more than once, right? So in other words, the problem for this one is gonna be 1. It's gonna always happen. Okay, it's gonna always happen. Okay, so the probability of that part is 1. So I don't know. So I don't know. See, if we said A is the event that you're gonna observe more than once of one value when you roll a die 7 times. Okay, then the probability equals 1. Okay, so we know that, right? However, if, let's see, I don't know, if I roll, let's see, if I roll a die, let's see, 5 times. Okay, 5 times, and then what is the probability that at least one value is observed more than once? Okay, so let's think about that. Well, the thing is, if you consider this problem straightforward, you're gonna have a lot of different cases, right? It's possible that you roll a die. For example, you can observe a value 5 times in a row. So it's all 1s, all 2s, all 3s, all 4s, all 5s, or all 6. Or you can observe, 4 out of 5 times for 1, or 2 out of, right? So in other words, if we strictly look at this problem, it is not that straightforward. Okay. So the good thing is we will learn probability. We know that we can use one concept to solve this type of situation perfectly. What is it? Well, it is called the complement. Okay, complement. So in other words, so again, if we let, if let B is the event that, at least one value observed more than once. Okay? When you roll the die 5 times. And then, so it's complement Do you agree that it is what? If there is no repetition, right? Observed. In other words, each one is different. So we can actually figure out the probability of that very easily. So as you can see that the probability of B complement, if you roll a die 5 times, the number of the combinations is going to be 6 to the power 5th, right? However, if you want, each time it is different. So how many combinations you're going to have? Well, not a lot. Why? Because the first time you can have 6 choices, right? But then the second time you roll, you're going to have 5 choices, right? Because you need to exclude the one that you get from the first time, because you need to make sure there is no repetition. And then third time, and then the fourth time, and then the 5th time. Okay, so this is the probability that there is no repetition. Okay, there is no repetition. Okay. Or you can right, or you can think about it as 6 chooses 5, right? And then, so the probability of getting at least one value is observed more than once. Do you agree that the probability it is equals 1 minus of its complement? And then we done. Okay. So this is this problem here. Okay. Now let's move on to look at the second one. So there are 36 students in class, and we have a professor want to choose this 18 students at random. So what is the probability that you or your friend Joe are among the chosen students, okay, of the chosen students? So, okay. So why I talk about this problem is exactly same logic compared to the first one. Because let's see, if we set the event A as you or your friend Joe are among the chosen students, okay, then do you agree that the complement of this event is going to be both you and Joe are not chosen, right? Are not chosen. Okay. So you see, we have 36 students in total. So we have you, and then we have a Joe, and then we have the rest of the 34, right? So the probability of a complement is going to be what? First of all, the denominator is going to be 36 chooses 18, right? But if you want you and Joe are not choosing, So meaning that we just need to have a 34 chooses 18, right? And then do you realize that that probability of you or Joe are among the chosen students, just minus its complement, okay? So we're done. Okay, so this those two problems I think very good to use the idea to talk about the complement concept. Okay, so I'll stop here. Thanks.